Hello. This tutorial will assist with assignment 9.7b, home learning for day 2 of volume composite figures. So each of these problems involves finding the volume of multiple figures and then adding them together or subtracting them, just depending on what the problem says. So for number 1, this is to determine the total volume of the cube and square pyramid. So we're going to find the volume of the pyramid, find the volume of the cube, and then add them together. Now, what I want you to do first is write down exactly what the problem's asking for. So volume of, you can just say the figure. All right, so we've got cube here, or it's a rectangular pyramid technically, or rectangular prism, and then we've got the pyramid. Okay. Now remember and keep in mind, whenever it's a pyramid or a cone, you're going to have to divide the product of the area of the base and the height by 3. For a prism cylinder, we don't do that. So we've got, it's a cube, so that means it's going to, the length and width and the height, they're all going to be the same. So it's length times width times height. Okay, so 16 times 16 times 16. Okay, that's going to be your rectangular prism. Plus, and then for your pyramid, now this one, we need the height, and we're given the slant height, so we have to use the Pythagorean theorem to determine the height. Okay, so we've got 10 here. Okay, and then this is what we need is the height, and then we're gonna go halfway, so that would be 8. Okay, so you would do 8 squared, h squared plus 8 squared equals 10 squared. Okay, and then you would work all that out. And then for pyramid, it's going to be area of the base, which is times height divided by 3. So to get the area of the base, it's just 16 times 16. Height is what you're going to get right there. Okay, and then you're going to divide that by 3, and then you'll just add the 2 up. Okay. All right, for number 2, it says dimensions of the rectangular solid. It's 5 by 9 by 12. And let's just say that this is 5, 9, and then altitude. Altitude means height, so that's 12. We got a hole here that's a triangular prism. So you'll find the volume of the, you're finding the volume of the figure, find the volume of the rectangular pyramid, or rectangular prism, and then you'll minus the volume of the triangular prism. Okay, so for the rectangular prism, pretty simple, just like you did up there. 9 times 5 times 12. Okay, minus, now for the triangular prism, we're not going to divide by 3. This one can be a little bit, is going to be a little bit tricky though, because we've got, so again, the volume, or the area of the base, area of the triangle, and times the height. Whoops, we're not dividing by 3. Okay, so it's just the area of the base times the height. Height is going to be 12. It's the distance between the two bases. Now, we've got a key here is noticing that it says equilateral. Equilateral means all the sides are going to be the same, so 3, 3, and 3. So what we need to do is we need to find the area of this. So we need to find this distance right there. And what's going to happen is if we draw an altitude there, we can have a right triangle. Okay, and that's going to be 1.5 and 1.5. Now I'm going to just actually draw one part of it. Okay, so we've got 1.5, 3, and so this is a 30, 60, 90 triangle. Now we could use the Pythagorean theorem. If you want to do that, that's fine. That's one way. But it might be quicker, easier for you if you can remember the relationship between the small side and the long side. If you remember, it's radical 3. So we would do radical 3 times, so actually you have to do that out on a calculator, so radical 3 times 1.5, just like that. Whatever number you get there, that's going to be the height. So that's going to be quicker than what you get right here. But either way, you should come out to the same answer. That's going to come here in here for, now this is the height, just to be make sure we don't get these confused. This is the height of the prism. Okay, so that's this right here. This is the height of the base, the triangular base. So height, so the area of the triangle, it's base times height divided by 2. So this right here is going to go there. The base is 3, and that was the original. So that's 3 right there. So whatever you get right here, multiply it by 3, divide by 2. That gives you the area of the base, the triangular base. And then you multiply by the height, which is 12. That gives you this right here. Okay, and then you subtract the 2. All right, number 3. All right, so you got a well built out of cement. Says the wall will be 4 feet thick, so that's going to be 4. I'm going to just draw kind of the top like this. Okay, so that's going to be 4. Height will be 20. Inner diameter is 5, so that's 5 in here. It's a little bit bigger. And that's 5, so that also means that's going to be 4 there. Okay. It says the outer wall needs to be painted. How much paint is needed to the job? So what we're going to do is we're going to find the lateral area of this cylinder. So lateral area, remember surface area will be the area of all the surfaces. So that'd be 2 circles and the rectangle, which is the lateral face. But lateral area does not include the area of the bases. So we just need to find the area of this rectangle. So remember the covering, or the outer, ends up being a rectangle put together. So it's straight, and then it comes, when you fold it, it becomes a rectangle. So we'll represent it like this. So we're just finding the area of the rectangle, and then let's see. So 20 is always going to be the small side, and then this right there is the long side, and that's the circumference of that circle. So 2 pi r. So the radius, so the diameter here is going to be 8 plus 5 is 13. Okay, and then so the radius will be 6.5. So that is what's going to go right there. Okay, so then you just put 6.5 there, multiply all that together, multiply by 20, and that is going to give you the area of that lateral area right there. That's it. All right, last one, number 4. So you got a storage bin that is a cone and a cylinder. It's asking for the volume of both. So we're going to find the volume of the cone, volume of the cylinder, add them up. What does it say? The radius is 7. So from there to there is 7. Okay, so we'll use that for both. Overall height of the bin is, so from there, there's 27. Okay. Altitude of the conical section, that's the cone, is 12. Okay, so to get the height of the cylinder, 27 minus 12 is 15. Oops. Sorry, I didn't realize you couldn't see that. So the whole entire height is 27. The conical height is 12, and so we get the 15 by doing 27 minus 12 to get that. So for the volume of the cone, remember that's just going to be pi r squared times the height divided by 3, and this is just going to be pi r squared times the height of the cone and of the cylinder. All right, so radius is going to be 7, so you're going to put 7 here, 7 there, and then the height for the cone is 12, so 12 goes in there. I don't want to get, so 7 for the radius, for the cone, 12 for the height, work that out, and then for the cylinder, 7 goes there, 15 for the height, multiply all that together, so then we add the 2 up, and that's it.